Alright, welcome to everybody in Videoland and everybody who's here in the real world. So today I'm going to go on with my solution to assignment 2, but I thought I'd show you something that's kind of cool, which is that Unity version 3 has come out and it has a whole bunch of really interesting features. If we can look, I really like the look of this. There's a whole, I downloaded it this morning and been playing around with it. There are a lot of interesting things that it can do, but I can't actually read that from here. That's not the page that I was looking for. Yes, this is the page that I want to see, the what's new page. The nice thing from your point of view, or at least from the teaching you had a program point of view, so lots of really cool stuff about much better lighting, much better sound, and some really interesting effects and stuff. But the most interesting thing of them all is this, well, from my point of view, is this one. Unity now supports what's called source level debugging, which basically means that we can actually go and step through our code and see it and watch it execute as we do it. So I'm going to, which is a really handy way to help you understand what's going on in a piece of code. So I'm actually going to turn that off. This is Unity 3. They've changed the colors. It now looks completely black from your point of view. That's great. Let's see whether we can change it back to the old don't use the pro skin. There we go. Now at least it's vaguely visible. Right. The new version is all beautiful matte black, so you know, black on black on black. It makes for really good overhead projecting, obviously. So the interesting thing now is that so Unity's always been based around this thing called Mono, which I'll put over there. So Mono, Mono is a separate editor. It's an editor, a bit more featureful editor than the standard. Actually, I won't show you that because that's the solution to today's tutorial. It's a bit more of a featureful editor than the usual built-in Unitron editor. It's a programmer's editor for writing code independent of Unity. I mean, lots of people use this for writing C# code in particular. The really nice thing is if we open up one of our Unity projects, say we open up the missile command project that we were doing before, I'll save that. Oh, whatever, don't, okay. Let's just call that scene. Go back to here. Twiddle our thumbs while it loads. There we go. So there's our scene. So this was our game, right? We got to this point where we had things falling from the sky. Now, what we can do, so in the preferences, in Unity preferences, one of the options here is the script editor. So normally this will be use the built-in editor Unitron, which is what you'll find. You can you have also the option for using MonoDevelop. You might have to actually browse and find where MonoDevelop is, but if you install Unity 3, then you come down here or wherever you find Unity, there's MonoDevelop is a part of Unity 3. So it's a separate application, but it's distributed with Unity 3. So that we can use that as our editor. If we do that, then if we go up here, I think it's in Assets, yes, here in Assets, Sync MonoDevelop Project, what happens is it opens up MonoDevelop and hopefully it's loading. If we twiddle our thumb, wait a little bit longer. Come on. It didn't take so long last time I did this. Of course, if this doesn't work, we're all screwed. So a lot of weather we've been having lately. How about that local sporting team? Okay, well this doesn't seem to be working. That's good. Come on, what you doing? Let's try that again. This is brand new software. Never use version 0 of anything. It's my advice to you. Let's try killing that and try and do that again. Force quit. Let's try doing that again. Go back to here. Yes, I know. Go away. Sorry. Ignore. Sync. Is this going to work? This is really cool if it works. It worked this morning. Yes, and yes, and load the thing. There we go. That's much better. So like in the other editor, we have our code that we can edit. But the nice thing in this editor is we have this bar down here is the to the left of the code is the breakpoint bar. So if, for example, here, when an object in the code where our objects trigger something, so far if we wanted to debug it, we've been relying on printing out things when that happens. But what we can do now is I can actually stick a breakpoint in there. And a breakpoint says that when you get to this point in the code, stop and show me what's happening. And so now I can go run debug, and this will launch. This launches another copy of Unity. So we've still got, if we have a look, we've still got the old copy of Unity that we're editing in, where we've now launched a separate copy of Unity. And if we now play the game in this new version of Unity, is this the new one or the old one? Whoops. I think that's the wrong scene. Let me go back to the other scene. I want to go to scene 2. If we play the game here, then when the block hits the ground, everything stops. Right? Because what we've done is we've hit this breakpoint. And so you now see in the code, that line of code is highlighted because we've got to that line of the code, and because we had a breakpoint there, we've stopped. Now the nice thing is that now we can actually look down here in the bottom window. Here are all the variables that we've got at the moment. We've got 3 variables in this context. We've got the this variable, which refers to the entire script. We've got the other variable, which is the variable that we got in as a parameter. And we've got the what variable, which we haven't assigned anything to yet because we haven't executed this line. And if we look at the this variable, we open that one up, we can see a bunch of stuff that doesn't mean, well, this doesn't mean much to us. But what we can see here is the 3 variables that we declared up there. Falling speed, axis, and turn speed are down here. And turn speed is 180, falling speed is 5, and axis is of that value. And so we can inspect the values inside as we go. And if we come up to here, there are 3 little buttons up here in the menu bar. And if we look, they're called step over, step into, and step out. Step over runs a single line of code. Step into will go into a function and step through the lines of code in that function, and step out will run until you finish the function. So the easiest one that we mostly want to do is just step over, which just runs a single line of code. And so now we've executed this line, and now we can come down here and see that the variable. Oh, that's interesting. I don't know why that has changed, but we can execute each line of code and see what happens after we've executed each line. And then now it's gone back to, there's also I don't know how you do it, whether there's a button for, yeah, there's also a button for continue execution. So now we can continue the execution, the code will keep running, so we should be now back, if we now look back at the game. Oops. Oops, which one's the game? Sorry, I can't do this while looking backwards. Yeah, so if we continue the execution, it should keep, that's curious. Yeah, to continue the execution, it keeps running until another one hits the ground, and then it comes back into this function. So the nice thing about this is if we have a complicated piece of code, so it's not so interesting for that piece of code, But if we have a longer and more complicated piece of code, we can actually step through it line by line and see what changes as we execute that piece of code. So if, for example, I stop this and maybe have, for example, in here, I don't know, for no particularly good reason, a for loop. This editor has this nice feature where it'll actually, if you start typing the beginning of something, it'll suggest what it might be, except that it seems to go overkill and it substitutes in when I don't want it to. But if I did this sort of I is less than, stop substituting. This is why I don't use this editor. Maybe I should be able to turn that off somehow. So, you know, if I put that in there, which doesn't do anything for what, doesn't make any sense for our code, but if we now run that in debug mode, it opens up. Oops, it's going to, yep, okay. So it opens up a new copy of Unity. It's a bit annoying that it has to open up a new copy, but that's the way it goes. We'll open the scene that we want, we'll run that scene, and now as soon as something hits the ground, we hit the breakpoint. And now if we step through this, you'll see it step through that 5 times. And if you watch the variable, oh, I can't see the variable I. That's weird. I don't know why. Normally the variable I should turn up down here. I don't know why it's not turning up. Anyway, it gives you a way of stepping through your code and seeing how it executes, which is like a really valuable thing when you're working out what's going wrong in your code, why it isn't doing what you want. You can actually step through it and watch as it executes each line, and watch all the variables as they change. Although in this case, for some reason or other, we can't see that variable, which is a little bit annoying. We should be able to. Why can't we see that variable? I have no idea. Actually, I don't know why those aren't turning up at all. That's interesting. If you define the variable outside. Yeah, but we should. No. We can't get at any of the variables for some reason. Let me just turn that off. Quit. Anyway, so it obviously isn't quite there yet, but it's a nice feature that if you have trouble understanding why a piece of code does what it does, you can actually walk through it and see it execute, and it'll give you some better idea about what's actually going on inside your code. Whereas at the moment we can only sort of pause in between frames, now we can actually pause in the middle of a piece of code and execute lines of that code until and one by one and see what changes. So this is a very useful feature, and like I use this sort of thing all the time in debugging in other programming languages. It makes it so much easier to be able to actually watch your code execute. Anyway, that's an aside. I'm going to go back to using Unitron because that editor bugs me a little bit. Use built-in editor. Okay, cool. And we're going to go back to doing what we were doing with the that game. So what we've done so far is we've made a launcher. Is that going to open up in Unitron? Yes, there it is. We've made our launcher, and we've made a script for our targets, which is that one. And I'm going to remove that bit that we just added to it. So let's get rid of that. And oops, no, that's right. So when we collide with something, we're going to destroy it. What we actually want to do here is, at the moment, anything that we collide with will destroy the game object. So we'll destroy the falling target. Now we probably don't want to do that on anything we collide with. For example, if 2 targets collide with one another, it's unlikely to happen in the game, but it shouldn't. But we don't actually want them to destroy each other when they collide. Right? We want them only to be destroyed when they hit the ground or when a missile hits them. So what we're going to do, just to check that, what we want to do is say if something, then destroy. And what we want to have here in here is some sort of test about if we've hit the ground, then destroy ourselves. What we could do is say if what.name, in fact we'll just do that in here, if what.name equals ground. That's one way of checking if we've hit the ground. That assumes that the thing that the ground object here has the name ground, and we've got the spelling right. And notice this is something I might not have pointed out before. We can do equality testing on strings. So we can say this what.name is a string, ground in inverted commas is a string, and so we can test if two strings have the same value by doing equals equals. Now note that that's different to that, right? The string capital G ground is not the same as the string little g ground. And if you asked if they were equal, it would return false, because they're actually quite different strings. If you want to see whether the two things are the same, barring capitalization, then you've actually got to go through and compare. What you probably do is make make both strings all in lowercase, and then compare those two lowercase or something like that. There's no easy way to say, is this string capital G ground the same as that string lower G ground, and make that just automatically return yes. So in this case the ground is capital G, so if that should now only destroy things when they collide with the ground. And that's good enough for what we want to do here, so we'll leave it at that. So the next thing I want to do is create our missile launcher. So what I'm going to do is create, I'll make it look a bit different to this time, create a box about there. Let's put that in the middle of the screen. 0, 0. Is that where we want it? Okay, let's bring that a bit closer to the camera. Actually, let's do this. Let me change view so I can see better. 3, is that around? Yeah, okay. So now I want to bring that box closer to the camera. So let's put it about there. And so that's the base of our missile launcher. So let's call this missile launcher. And we're going to have another part on that, which is a cylinder. And we're going to scale, I might actually even scale that bit up a bit. So let's scale that up to be a bit bigger. So let's make that a bit wider, maybe about that wide, and a bit taller. Yeah, make it bigger all around. There we go. Now we want our cannon. We probably want the cannon to be a bit longer than that. So let's call that cannon. We want the cannon to be about that long. And we're going to be rotating this I'm grabbing it in the wrong scene. We're going to be rotating this cannon, but if we rotate it on its own at the moment, it'll rotate around the center point. So if we move in and focus on that, if we try to rotate that, it'll rotate around. So I'll show you, if I rotate around the x-axis, 60 degrees, it rotates around the center of the thing, which is not what we're going to want in the game. We're going to want it to rotate around some point down here at the bottom instead of the middle. So what we can do is with that trick we've done before, which is we'll create a joint. I'll move that joint. I'll move that joint so it's at the bottom of the cannon. So the joint is an empty object. We're going to position it there. Okay, so the joint is currently there, positioned in the middle of the cannon. We're going to move it down here to the bottom of the cannon, to about there. And now what I'm going to do, I put it inside the cannon just for ease in positioning it, but I'm going to take it out here, and I'm going to move the cannon inside the joint. So now when I Now the cannon is that cylinder, but the joint is actually, that's interesting, why is that showing there? That should be, Okay, this is something I only just discovered. There's this button up here marked center, and you press it, it either shows center or pivot. If it shows center, it shows the center of gravity of the entire object. So if you've got an object with lots of parts, that will currently show the center of gravity. But that's not where it rotates around. It rotates around the pivot. So if you select that again, it'll show the pivot of that object. And this is the point. So a couple of people in labs I've found have got that button marked on center where they wanted it on pivot, and the answer was the display was getting a bit confusing. So that's what it is. I didn't know about that button until today. So there you go. So now if we rotate that joint, so if we now go to the joint and rotate it by 60 degrees, it rotates around that point. And that's the kind of behaviour we want. So that's good. Now we want to attach that joint to the missile launcher, and we'll move it to the middle of the missile launcher. So it's about there and about there. And what? That's not the middle of the missile launcher. Joint is at 0. That's weird. Why is it doing that? Oh, yes, it is at the middle of the missile launcher. It's just looking. Oh, okay. That's because I haven't got. What is that? That's because Oh, the light in the scene. Okay, I think it's the light in the scene. Let me. It's just an optical illusion. If I grab the light and drag it. Where's the light? Drag the light up a little bit and make it and rotate it a little bit. There we go. Oh, actually. Okay, yes, we are. Okay, this will make more sense if I do this. If I grab, create material, drag that material onto the missile launcher, give it a different colour, then you'll be able to see what we're doing. There we go. Okay, so you can see you can't see here anyway, but you can actually see that is pointing out sticking out of the top of the box. It's just kind of hard to see on the screen. That cannon is a bit bigger than I want, so I'm going to actually scale it down now that we've done it. I think I'll make that only about 1, and I think I'll make it a bit narrower, just for the hell of it. There we go. That looks better now. Okay, so now we have our cannon, and if we have the cannon attached to the missile launcher by this joint, so that when we rotate it around the joint, it will rotate appropriately. Now we need to add a script to this to allow us to rotate it. So we'll make a new script, JavaScript, and this will be called track target. If I can spell, yes, good. And what I want this to do is track the given target, of course. And so we have a variable target, which I'm going to say is a transform because it's easiest to track an object in terms of its transform. I think, no, it's probably better to make it a game object. Let's make it a game object for now and see what happens. So we've got a game object that we want to track, and we want to make the cannon point at that game object all the time. So now I've got to remember how to do this because I've just forgotten. Okay, so the easiest way to do this is just to say, so sometimes we may or may not have a target, right? So if we don't have a target, the variable target's going to be null. And so initially it's going to be null. So if the target is null, then we don't want to do anything. But if the target isn't null, so if the target is null, the cannon's just going to stay where it is, and nothing's going to happen. But if the target isn't null, we want the cannon to point at the target. The easiest way to do this is to do transform look at target.transform. I think that should do the trick if I'm remembering correctly. Let me check that in the documentation. Help, scripting reference, transform. There's a look at, so yes, so this look at and can take another transform that it's meant to look at. So that should do what we want. But like I've said before, look at makes the forward vector point at this. And so at the moment, the forward vector of that joint, which is the thing that has the script on it, the forward vector of the joint is pointing into the screen. Can't quite see it there at the moment, but it's pointing inwards. So we don't want that. We actually want, at the moment, what we want is the up vector to point at the target. So what we're going to do is that trick that we've done before, which is to rotate the joint around so the forward vector of the joint is pointing in the direction we want. So we're going to rotate the joint by 90 degrees around the x-axis, like that. Whoops, no, not negative 90 degrees, because now it's pointing downwards. Negative 90 degrees. So now the joint is pointing up, but the cannon is pointing in the wrong direction because the cannon rotated when we rotated the joint. So now we need to rotate the cannon back again. So we rotate the, oh no, oh yeah, okay, that's not going to work. I've got to move the joint. Okay, just made a mistake. I'm going to, so I want to rotate the cannon back again, but we actually now got the joint attached to the wrong part of the cannon. So now what we need to do is move this back to where it came from. So that's about 0, 0, and now we need to move it up to wherever that is. Let's hide the missile launcher so that I'm not looking at it. There it is. So now the cannon is there, the joint is there. So we actually want the joint the cannon a little bit lower down. That looks about right. Let's bring the missile launcher back into the picture. And now, so now we've got our joint. The z-axis of our joint is pointing up along the barrel of the cannon. So, so now if we rotate if we make the joint point at a target, it should point at it should make the cannon point at that target as well. So now if we set, let's add a target. Let's just grab a target into the world, drop it in, put that target at somewhere in the middle of the screen. That looks like right. So, and let's actually just make the joint, let's add that track target script to the joint. There it is. And make it track that target that we've just added. So there. And we'll turn off the target launcher for the moment because we just want the one target going around, so we'll turn that off. Now if we run, hopefully, there we go, it's tracking. Our cannon is nicely tracking the object on you can't see it very well from this angle, but actually let's zoom out. Let's move this one over a little bit to there. Whoops, what's that? Oh, whoops, don't move that. I want to move the target, not the target launcher. Move the target out to there. So now you should be able to see, I don't know if you can see that on the screen, but the cannon is actually tracking it as it falls down, which is nice, which is what we wanted to do. But we don't want just that target in the world, so we're going to delete that target for now. So now that we've deleted the target, this has gone back to missing. Whoops, oh, that's interesting. I didn't know we could do that. There you go. And so now if we run that, it won't do anything because the target is null, and when the target is null, the update loop doesn't do anything. Which is again what we want. We want the cannon not to move when the target is null. So now what we want to do is have a way of setting targets. And the way I'm going to do it is when we mouse over a target, that's going to be the new thing we start tracking. So we detect mouse over events by, detect mouse over events by another event handler in here. which is function, now I've got to remember, on mouse enter, I think it's called. On mouse enter, yep. So when the mouse enters a target, now what we want to do is tell the missile launcher to start tracking that target. So we need to do that, to send that message to the missile launcher, we need to have a reference to the missile launcher around. So every single target is going to need to know about the missile launcher in order to send that message to the missile launcher. So it's going to have a missile launcher variable to keep track of that. Missile launcher is going to be, now this isn't going to be the object. What we want is a reference to this script. We want a reference to the track target script. So, because we need to set the value of target in the track target script. Oops, not target, track target. I'm really not getting this right today. So, now the problem we have here is that if we just created a target in the world, we could, with that script on it, we could set the value of missile launcher. So we could grab that joint, drop it in there, and that would point to the track target script on that joint, and that would do what we want. But we don't want it but what we want to do is we don't want that to be a fixed object in the world. We want to have it on the prefab. So here on the prefab we have the same thing. We have the falling target script, and we have this field for the missile launcher. Unfortunately, what we can't do is drag that into there. It doesn't let us do that. We can't make a prefab refer to a specific object in the world. I'm not exactly sure why we can't do that. There's probably good reasons why we can't. I can't think of it at the top of my head. But that's a rather annoying thing in Unity, is that if you want to make prefabs and you want those objects as you create them to reference other objects in the world, you can't just set that up in here. What we've got to do to set that up is put something in the start script which initializes to that value. So what we're going to say here, when we create the object, we run the start script, we're going to set missile launcher equals, now we're going to say game object dot find, let's see if I can get this right. So we find the missile launcher object, then what we actually need to do is then get the component of that object, which is the track target component. So this is a little bit more complicated. I mean, this is not necessarily the way you had to do it in the assignment. It's just if you want to do what I'm doing, which is the automatic tracking. But yeah, so you get the use GameObject.find, which finds an object in the world with a given name. So the object that we're looking for is the missile launcher. And then we need to get the track target component of that object, and so we then call the getComponent method on the object we've got. So this is the same as, so that's the same in one line as basically saying, we just call it obj equals so that would be getting the object, and then we could, from that object, where I can't see what I'm doing, from that object we could then get the that's the same thing over two lines. It's just easier, given that we're not using this object other than to get this field, to get this component. So we get that command will get the object. We then take that object and get the component. Well, we don't really need to worry about having the object itself hanging around. So we can do all of that in one command just by that first part gets. This first part gets the object. Once we've got the object, we can then call a method on that object, which is to get the component. So we can string together stuff like that. The dot operator allows us to. The dot operator is what we call left associative, which means that it does the left bit first and then does, so this dot happens first, then this dot, then the next dot, then the next dot, which means that this code gets the object, then from that object we then can call getComponent, and then from that component we could then call some other method, and from that we could call some other method, and if we wanted to. Doing more than 2 on one line gets a little bit unreadable, so it's up to you as to which way you prefer. In this case, I think it just makes sense to do it all on one line, and that when we save the response into missile launcher. So now we've got the missile launcher having for time. Cool. So once we've got, so when a mouse enters the, so when the mouse enters an object, we'll just set the target equals game object. So when the mouse is over this target, we'll set the target. Well, then the missile launcher's target is now equal to the game object. So we take this track target script that we've got a reference to here, we access the target variable and we set the value of the target variable to the current object. Now, hopefully if we come back over here, turn our target launcher back on, make sure that we haven't made any mistakes in the code. And as I mouse over, I'm not getting what I want. Let me actually maximize that. Let's go back to the other view. Where am I looking? Layouts. Wide. Let's see whether this works. And it's not working. And why is it not working? It would not be working because... Why do you think this isn't working? On mouse over? Is it? What's the... On mouse down is when you click on it. On mouse, I'm pretty sure on mouse enter is when you, yeah, on mouse enter is called when the mouse enters the collider, so that should be right. Let's just check. Print targeting plus name. Okay, so null reference. Okay, what was that? I got an error there. Object at reference not set to an instance of object. That would be because, okay, somewhere along the line, this isn't working. And that isn't working because, because the missile launcher, okay, I got the wrong name. So the missile launcher, the track target is on the joint, not on the missile launcher, right? So I'm saying find the missile launcher, then get the track target script. There is no track target script on the missile launcher, so this is returning null. So what that should actually be is joint. Now it should work, let's hope. Yep, okay, so now every object that we need to move I think we'll move our entire missile launcher back a little bit. Yep, so now every time we select a new object, it starts tracking that object. We don't have to click on anything, we just have to mouse over it and it tells it to track that new object. It's not doing it very neatly, but notice that it's jumping between them automatically every time I track a new one. The cannon jumps. In my version, I wrote a little bit of extra code to actually make the cannon sweep across to the new target. That's getting a little bit more sophisticated than that I really want to show you at the moment, and we're running out of time. Okay, so we've got it working now. That when we target a new object, we tell the missile launcher what its new target is, and then the missile launcher starts tracking on that target. And very simple to track it. We just use lookat to track in this case. Now the last thing we need is to work out when we click on a target, we want to. When we click on a target, we want to actually fire a missile. So yes, I know we're running out of time. Stop reminding me. So function on mouse down, so that's when we particularly click on it. And now we want to do is tell the missile launcher. In this case, so in the case here, we're just setting a variable on the missile launcher. In this case, we actually want to run a method on the missile launcher. We want to tell the missile launcher to fire at, well, at this object. So fire at game object. And now the missile, we need to add that method to the missile launcher. So keep doing that. So the missile launcher needs a fire method. And now what this is going to do, so we should just print fire. There we go. Actually, we need to know, we need an argument here, which is that the what we're firing at. So we're going to fire at, actually we've already got the target, we don't really need to fire it, we don't need to know what we're firing at. So let's leave that out. We don't need to know that, because we already have a target, so that's fine. So, track target. So we're firing at the current target. What we're going to do is set up a missile prefab, because we want to create a missile. That's going to be another game object. We're going to say var missile equals instantiate missile prefab. Now, we want to work out where are we going to, so we need to know where in the world we're going to create this missile. Now, there are lots of different ways we could specify that. But what I like to do is this. We can actually come in here, and here's the cannon. What we want to do is create the missile right here at the end of the cannon. Now, we could go to a lot of trouble to calculate what that point is and work it out. But the much easier way is to try to get Unity to do that calculation for us. The way to get Unity to do that is just to create another empty in the world. Let's call that empty launch point. And then we attach that launch point to the cannon, and we put that launch point at exactly where in the world we want it, which is right on the end of the cannon. So actually, let's put it at 0, 0 there, and drag it up to here at the end of the cannon. Now, the nice thing about that is that that launch point will always be at the end of the cannon, no matter how we move the cannon around. So if we put a missile at that launch point, it'll automatically be at the end come out of the end of the cannon, which is kind of cool. So we can then, we need the cannon, the launcher to know about that. So let's call this launch point. We don't really want the whole game object. All we really want is the transform. So we'll say launch point is a transform. And now here's the script, here's the joint. So we put that launch point into there. Now we need a missile prefab, which I have one that I made earlier. Actually, no, let's make another missile prefab. So we create what we want our missile to look like, which might be a little capsule. We'll make it a lot smaller. 0.1, 0.1. There's a missile. Let's make it a little bit bigger than that. 0.2. There we go. And we create a prefab. Create, oops, down here. This is going to be our missile prefab. And so that goes into our script as well. So script now knows about the missile prefab, which is not going to work. And why is that not going to work? Because we haven't actually put that in there. That's right. Where's our capsule? Let's call that missile. So put our missile into our prefab there. Okay, now we can drag that prefab into here. Okay, so now we have a missile prefab and we have a launch point. So we can say the missile, we create a new missile out of that prefab. We say missile dot transform dot position equals launch point. The launch point is a transform, so we can say launch point dot position. We can also do the same for the rotation of the missile to make the missile rotated in the same way as the launch point is rotated. And now, hopefully, if we remove the missile from the world and we play, then when I click on an object, it creates a missile. Now, you can see the missile I created is right there, which was the point where the cannon was when I fired. We don't have a script on the missile at the moment, so it's not doing anything interesting. But every time I click on a new object, I create another missile at the appropriate launch point, wherever the cannon is pointing. So the last thing to do then is to create a script on the missile to make the missile track the object or fire towards the object. I'm not going to write that by hand because we don't have time. So I'm going to show you is the one that I wrote previously, because I want to finish this up today and get on to other things next week. So the missile script here. So the missile script, I decided that missiles should only last a certain amount of time. So a missile, as soon as it's created, it calls destroy with a 5-second lifetime. So if the missile doesn't hit anything within 5 seconds, it automatically destroys itself. Otherwise, all the missile does is move towards the target. So we're making the missile track the target, so it looks at the target. Now we could, like I said, this has that issue that, that it makes the z-axis point towards the target. In this case, I didn't want to do the messing around with putting a joint inside the, putting the missile inside a joint. So all I did was make it look at the target and then rotate it 90 degrees around the x-axis, so that rather than the z-axis pointing at the target, the y-axis is pointing at the target. So I mean, the good thing about this is even though I'm rotating it point that way and then I'm rotating it 90 degrees, you never see that because the whole frame, all this code is executed before the next frame is rendered. So you don't see the missile flicking backwards and forwards. All you do is I create the missile that way, I rotate it that way, and then the next time the missile is drawn, it's pointing that way. So this makes the missile point in the right direction. This makes the missile move forwards at a standard speed. We've all seen that code before. And then the only other interesting thing on here is when the missile triggers, when the missile collides with something, we need to check what the missile has collided with. If the missile has collided with the target or the missile has collided with the ground, we've decided we're going to destroy the missile and remove and set the target equal to null. Actually, I don't know why we need to set the target equal to null if we've just destroyed the object. But so if we just destroy the object, I don't think that's necessary. The other thing we need to do here, though, in the code, the way that we've written it, is actually what we should do is separate this into two cases. If the missile hits a target, then we should actually destroy that target. So let's destroy other dot game object. All right. So that. And we also need to destroy the missile. Right. If, on the other hand, if we just hit the ground, then we just destroy the missile. And we don't destroy the ground because that would be bad. Now, where before I was using, so now I'm using tags to identify things. So before what I did here was to say if other dot game object dot dot name equals ground. So I said if the object that we've collided with has the name ground, then we've hit the ground, so just destroy the missile. But The targets won't all have the name target. The targets will have different names depending on when they were created, but they'll all have this tag target attached to them. And they'll have that because when we created the target prefab, well, I didn't do it in this case. When we create the target prefab, we have the option to give it a tag. And so up here in the inspector, there's a tag field. I've already created a tag called target. And so now every target will have this tag called target. Excuse me. So one way of checking whether something is a target is by seeing if it has the target tag on it. And so we'll have lots of different targets. All the targets might have different names, but they'll all be tagged as target, and so they'll all be true when we compare tag to target, and so then we know how to destroy the target and destroy the missile. And that's basically all the code we need for implementing this. Any questions about any of that before we run off? Any bits that anyone didn't follow? We don't really have. Okay. Well, so today's lab will be doing some stuff with GUIs and working on your assignment if you want. I'm trying to get the SS to install the Unity 3 on those machines sometimes this week, so you can have a play around with that, actually watching code execute in the in Unity 3. But that'll probably be next week's lab because I don't think it'll be installed in time. Thank you all. See some of you in shoots, some of you later.